All right. So today we are going to be learning about how to factor polynomials. And I've split them into 4 different categories. The first one is going to be difference of squares. We've already talked about difference of squares. We kind of know what that means. Difference means subtraction, and squares is anything to the power of 2. So we would say x to the power of 2, which is the same as saying x squared. Anything to the power of 2 is squared. Now we have a formula that comes along with this. We got a squared minus b squared. That is going to turn into a minus b times a plus b. Now, you will always be given the problem in this form, a squared minus b squared, and it is your job to make it into this form, a minus b times a plus b. All right, now we have difference of cubes, and my apologies, I'm a little bit incorrect. It's difference or sum of cubes. You are either going to be dealing with subtraction or addition of cubes. And once again, cubes is just x to the power of 3. Anything to the power of 3, you can also say x cubed. And we have 2 formulas that go with this. One for our difference and one for our sum. One for addition and one for subtraction. So we are going to be working with a cubed minus b cubed, and that is going to turn into this formula here. Watch me write it, and then I will explain it. A minus b times a squared plus ab plus b squared. Now, you might be saying, how on God's green earth am I supposed to remember that formula? I'm going to help you out. S-O-P, SOP. S-O-P, this stands for same, opposite, positive, or plus, either way. Let's look at our sign here. It is a minus sign. So we start with A, and then the same sign, which is a minus, B, times a squared, the opposite, and the opposite of a minus is a plus, AB, our P will always stand for positive or plus. So we're left with that. Then we also have sum of cubes, which would be a cubed plus b cubed. This will turn into a, what is our same, is going to be plus b times a squared, the opposite of a plus is going to be a minus, ab, and then p is just going to be positive b squared. So this is going to be your subtraction, and this is going to be your addition formula. And then we have trinomials with leading coefficients greater than 1. Should be a greater than symbol, my apologies. And then polynomials with 4 terms, which don't have any certain formulas, but they do have steps that we need to know. So let's go ahead and start with example 1. Okay, I know based on this right here that I am working with a difference of squares. I am seeing that it is subtraction, and then I am looking at a square right here. Okay, now I need to remember my formula for difference of squares. If you're taking notes in this video, refer back to that, but I'll go ahead and write it here. A squared minus b squared is going to be equal to a minus b times a plus b. All right, now remember, you are always going to be given your problem in this kind of format. A squared minus b squared. So we have 25x squared minus 16. I know that my a squared is going to be equal to 25x squared. And my b squared is going to be equal to 16. Here is my A, and here is my B. Now, I want to find what my A is by itself without that squared. So what I'm going to do is I am going to do the opposite of a square, which, if you remember from previous units, is going to be square root. So square root of A squared, what I do to one side, I need to do to the other. Square root 25x squared. Now, there's something very interesting when it comes to square roots and multiplication. What you can do is you can split them up. So I'm looking at square root of 25 times square root of x squared. Do not forget that a square root is opposite of a square, so they are going to cancel out, and I am left with A equals, we know that the square root of 25, you can go ahead and plug that into your calculator, is going to be 5 times, once again, my square root, and my square will cancel out. All that's left behind is x. So my A is equal to 5x. Then with my B, I'm going to do the exact same thing. I want to get B all by itself. So I'm going to do the opposite of a square and square root. What I do to one side, I do to the other. My square root and my square will cancel out. I am left with only B. And then you can plug this into your phone calculator at home. The square root of 16 is 4. I know what my A is and I know what my B is. I am going to plug them back into this equation right here. So we're going to start with A. My A is 5x minus B, which is 4, close parentheses, open parentheses, A, which is 5x, plus B, which is 4. And that is it. Hopefully, you'll get to the point where you won't have to go through all these steps and you can just skip it and immediately get your right answer. Now, this is something that I want you to do on your own. We are looking at 36x squared minus 4. It will be posted in the description below to do on your own. All right, now I'm looking at example 7. 27x cubed minus 125. Well, I know that I'm dealing with the difference of something because I'm looking at a subtraction symbol right there. And also, to the power of 3, another way of saying that is cubed. So I know I am dealing with difference of cubes. I'm going to go ahead and write that over to the side. Difference of cubes. And with that, I'm going to write my equation so I can remember it, so I can recall it. A cubed minus B cubed is equal to A minus B times A squared plus AB plus B squared. Great. Once again, we are given the problem in this format. So I know my A cubed is going to be 27x squared and my B cubed is going to be 125. Let me go ahead and write that out. My cat just jumped off the table, I'm sorry. A cubed is equal to 27x cubed, and my B cubed is equal to 125. All right, what I'm going to do is, we know how to do square roots, but we can also do cube roots. Once again, this is something we learned about in a previous unit. We are going to cube both sides. Very similarly to a square cubed, my cube root and my cube are going to cancel out. I'm going to be left with A all by itself. And just like we saw with a square root, we can split these two up. So I'm dealing with the cube root of 27 and the cube root of x cubed. All right, you can plug this into your phone calculator, and you will get that the answer is 3. And then my cube root and my cube will cancel out. All that's left behind is x. Now we're moving on to b because we've gotten my a. Now we're going to move on to b. Once again, I am going to cube root both sides. Cube root, 125. My cube root and my cube are going to cancel out, and I'm just left with b. And when you plug the cube root of 125 into your calculator, you are going to get 5. I now have my a and my b. I am going to plug back into this equation up here. A is 3x minus 5, because my 5 is my b. Okay, now I'm looking at 3x squared. Do not forget your parentheses here and here. Do not become lazy and forget them. Leave them there, they are important. Then we are working with a times b, which is going to be 3x times 5. 3x times 5. Plus, I'm going to go ahead and put in my parentheses so I will not forget later. B squared, which is just 5 squared. Now we are going to go ahead and simplify this very quickly. We don't need to simplify this part of our equation. That is fine as is, so I'm going to go and bring it down. 3x minus 5. But I can take this square and I can distribute it inside. So I'm looking at 3 squared times x squared. So I'm left with 9x squared plus my 3x times 5. Well, we know how to multiply that together. We are just going to multiply our numbers. So what is 3 times 5? That is going to be 15x plus 5 squared is 25. And that is our answer. You are going to find your A and your B. You are going to plug in and then simplify. You will very, very likely never need to simplify this part because it's just going to be A minus B. I cannot think of a time where you would need to simplify our first part. However, because of our second part having squares and multiplication, you will very likely need to simplify this part. You now know how to distribute exponents. We have learned how to multiply terms that have variables in them. And then I know you know how to square. There should be absolutely no issues, but if there is, please reach out. I'd be more than happy to help you out. All right, here is another do on your own. And once again, it will be posted in the description below. All right, moving on to example 3. Example 3. 64x to the power of 3 or x cubed plus 27. What kind of sign am I dealing with? Is this a difference or a sum? It is addition, so it is a sum. So I'm going to say sum of, and let's look at that exponent right there. Is that a squared or a cubed? It is a cubed because it is a 3. Square is 2, cube is 3. So I'm dealing with sum of cubes. Let me go ahead and write that equation out. A cubed plus b cubed is equal to a, we're going to start with the same because SOP plus b times a squared minus ab plus b squared. All right. Once again, it is given to me in this formula. Let's go ahead and find what our a is. I know my a squared is going to be equal to, not my a squared. My a cubed is equal to 64x cubed, and my b is equal to 27. All right, I'm going to go ahead and cube root both sides because I want to get rid of my cubes. 64x to the power 3 Well, I know that this and this will cancel out. As we saw earlier, I can split this up, so I'm dealing with the cube root of 64 times the cube root of x cubed. Cube roots and cubes cancel out. And then plugging into your calculator, we know that the cube root of 64 is going to be 4. I am left with x. Over here, I'm left with x. That comes right there. And then we know a is equal to 4x. All right. We got our a. Let's get our b. B cubed. My apologies. B cubed is equal to cube root 27. This cancels with that. I'm left with b. You can plug this into your calculator and you will get 3. Let's plug it into this equation. All right, my a, I'm starting off with my a is 4x. Our next part is plus b, which is 3 times a squared. Remember, do not forget those parentheses when you are plugging in things with an exponent, minus a times b, so it's going to be 4x times 3 plus b squared, which is 3 squared. Let's simplify. Once again, you're probably never going to need to simplify that if you have done this part here correctly. 4x plus 3. Distribute that exponent, so you have 4 squared times x squared. My 4 squared is 16. X squared stays just x squared minus 4 times 3, dealing with 12. Don't forget to bring your x back, plus 3 squared, which is 9 by itself. All right, here's another do on your own. Once again, it will be in the description. Okay. Now we are getting into trinomials. We know it's a trinomial because we can count our terms. Remember, when we were learning whether or not our polynomials were monomials, binomials, or trinomials, we start counting and we stop whenever we see a sign. So let's count. 1, stop, 2, stop, 3. This has 3 terms, so it is a trinomial. Okay. Our very first thing whenever we're dealing with a trinomial is we want to take out our greatest common factor. This is going to be the number that we can find in every single term. Okay, so my terms are 4x squared, 14x, and 6. Well, the good news is I'm not going to have to deal with any variables because I would need a variable in every single one to deal with it. Now let me look at my numbers. 4, 14, and 6. Is there a common number that can multiply to 4, 14, and 6? There is. It is going to be 2. I know 2 will go into 4 2 times, 2 will go into 14 7 times, and 2 will go into 6 3 times. So let me take out my greatest common factor. Take out my greatest common factor. 2, we already said 4 divided by 2, it's going to be 2x squared plus 14 divided by 2 is going to be 7. Don't forget your x. And then 6 divided by 2 will be 3. All right. Remember, we need to keep this greatest common factor with us. Keep this 1. Later down the road, when we check for greatest common factors again, we are going to throw out the greatest common factor. But we are going to keep the one we find originally. So we're going to go ahead and label this as step 1. Take out my greatest common factor. Step 2 is we want to combine our A and our C. You may remember your A, B, C's. It is going to be the number in each term. Step 2, like I said, is multiply your A and C. My A is 2. My C is 3. 2 times 3 is going to be 6. I'm going to go ahead and write that over here. Step 3, probably the easiest step, draw a large X. Draw an X. I'm going to go put that over here. Now, this X does not mean anything. It is not a variable. It is not a number. It is a visual tool that is going to help us. Some of y'all prefer the box method. That is totally all right with me. Step 4 is to put my AC, which is 6, don't forget that, at the top. 6. And my B at the bottom. My B is once again just going to be that number, 7. Now, our job is to find what multiplies to my top and adds to my bottom. What multiplies to top and adds to bottom. Well, let me think. You guys know how I like to do it. I like to write out the factors of 6. So I know 6 will be 1 times 6, 2 times 3, and then nothing else. And now I'm going to go through, and because I am not dealing with any negatives, I do not have to worry about subtracting. I am only going to add. 1 plus 6 is 7, and 2 plus 3 is going to be 5. Well, I'm looking for 7, so this is my winner. Now, these are going to be my 2 special numbers, 1 and 6. All right, now we are moving on to step 6. You are going to write your factors. Write your factors with our A in front. And I'm going to show you exactly what I mean. You are going to open parentheses. Our A is 2x. This is a positive 1, so I'm going to do plus 1 times 2x. This is my A in front. Plus 6. And let's not forget our greatest common factor from the very front, 2. Now, step 7, find the GCF in each polynomial. Binomial it would be because we are dealing with 2 terms. And throw it out. Don't forget, we are going to keep the one up here. We are going to throw this one out. So let's see. 2x plus 1. That does not have a greatest common factor. There's no number that goes into both 2 and 1 except 1, but we don't really care about that. So I'm going to write 2x plus 1, and then we need to find the greatest common factor in this one. What number goes into both 2 and 6? Well, that would be 2, and we are going to throw it out. That being said, we still need to simplify this. So we're going to find what 2x is divided by 2. Okay, 2 divided by 2 is 1, so I'm working with 1x, and that's just going to be x. And then 6 divided by 2 is 3. And this is my simplified trinomial. So now we have example 5, and this is going to be the last example I do with you. This is going to be a polynomial with 4 terms. We can count using our same method as before. 1, break 2, break 3, break 4. Now with our polynomial with 4 terms, we first want to make sure that this is in standard form. That's step 1. Make sure it is in standard form. Standard form. We can also take out a greatest common factor if we see one at this time, and I'm going to go ahead and make it easier on you guys. There's no number that goes into 3, 6, 2, and 4 all together. So we don't have a greatest common factor, and we're also missing a variable in each term. This term doesn't have a variable. Now, the question is this in standard form? Well, let's check our exponents, because our exponents should go from the largest, which is 3, to our smallest, which is 0 or none. Yes, our exponents do go from largest to biggest, 3, 2, 1, 0. Now, we are going to group 2 and 2. This is our second step, group. We are going to take our first 2 terms. That is going to be 3x cubed plus 6x squared, 3x cubed plus 6x squared. And our last 2 terms, 2x plus 4. Remember, we always need a plus between our parentheses. Need a plus between. All right, 2x plus 4. Now we are going to take a greatest common factor out of each new binomial. All right, so let's see what greatest common factor is in both 3x cubed and 6x squared. Well, I know that 3 goes into both 3 and 3 goes into 6. So I'm going to go and put 3 on the outside. But what about my variables? I have a variable in my first term and a variable in my second term. If you recall me saying, whenever we have a variable in all of our terms, we are going to take the lowest exponent, which our lowest exponent here is x squared. Now we need to take our 3x squared out of each term, 3x cubed and 6x squared. I'm going to go ahead and do this by putting them in fractions. It's a little bit easier to see in fraction form. 3x squared. All right. Very similarly to how we deal with multiplication, with division, we focus on the numbers and then our variables. So what is 3 divided by 3? Well, it's going to be 1. Whenever you're dealing with exponents, with multiplication, it is addition. With division, it is subtraction. So I'm going to do 3 minus 2. That is equal to 1, which will become our new exponent. So I'm going to work with x to the power of 1. 1 times x to the power of 1 is very simply just x. So we're going to go and put x there. Now I'm looking at 6x squared divided by 3x squared. 6 divided by 3 is going to be 2. And then x squared divided by x squared, you can know that you have the same on the top as you do on the bottom. Or you can do our method where we do 2 minus 2, which is 0. So I'm left with x to the power of 0. Anything to the power of 0 is just going to be 1. So we don't need to care about it. And we are left with 2. And I'm going to go ahead and put that back up in our binomial. All right. Now, what is our greatest common factor here? Well, I know 2 goes into 2 and 2 goes into 4. All right. So our greatest common factor is going to be 2, and we don't need to worry about a variable because even though this term has a variable, this term does not have a variable. All right. Same thing as I did over on this side where I divided each term by 3x squared by my greatest common factor. I'm going to do it here. 2x divided by 2. Well, 2 divided by 2 leaves me with 1, and I'm left behind with x. 1x is just going to be x. And then 4 divided by 2 is equal to 2. X plus 2. You may recognize these are the exact same. And that is exactly what you want. If what is inside our parentheses is not the exact same, then something is incorrect and we need to fix that. So that leads us to step 4, combine greatest common factors and parentheses. We are going to take my greatest common factors, 3x and 2, and we are going to add them right here, 3x squared plus 2. All right, awesome. And then we are going to take what is inside the parentheses and just kind of overlap them, plus 2. That is it. You can check for your greatest common factor here, but if you've done the previous steps correctly, you should not have any. All right. This is the do on your own, and that is it for this video. It is 10 questions, 5 of which I walked through with you. I would love to see those 5 done on your own. Bring them into class soon. All right, I hope you guys have a delightful day off. I hope it's very relaxing, and you have a good one.